Hi, I'm Stu Bailey, curator at the Wings Over the Rockies Air and Space Museum, and in this highly requested episode, we are going to take you on a deep dive inside the secret adversary training program, Constant Peg. American MiG pilot John Mann flew MiG-21s and MiG-23s as part of the Constant Peg program, and in this full-length lecture, he will share his stories. Now, we've got a lot to cover, so let's get on with it.
My name is John. I got to fly the F-4 at MacDill Air Force Base, where I checked out, at Osan, Korea, and then at Holloman Air Force Base in the D model there. And then at Holloman, I got to transition to the F-15. Then I was in a test squadron at Eglin, where we shot missiles at drones. Eglin Air Force Base is in the Panhandle of Florida. Terrible place to be assigned, as my nose grows. Then to Nellis to fly the MiGs. And then I got to go to Bitburg, Germany, and did Desert Storm. The whole long and short of that, I had a very fortunate career. So let's get moving. If we're going to talk about the MiGs and talk about the program, really, we need to understand some history. And everybody understands history, I'm sure, generally. World War I, our Air Forces were all new. Airplanes were new toys. World War II, toys weren't quite so new, but there was an awful lot of airplanes. Thousands of airplanes built, flown, bombs dropped everywhere, airplanes shot down. It was a mess. Korea was a little bit better. And we did really well in Korea in terms of air-to-air shoot-downs. We did pretty well in World War II also. But then along came Southeast Asia, and we didn't do so well. At the end of that, the Air Force said, we got to fix this. And so the Constant Peg program, the MiG program, was part of that. A couple other parts of that, if you're interested in history, is something called AIMVAL, ACEVAL. AIMVAL was Air Intercept Missile Evaluation. What kind of missiles do we need? Do we need a 5-mile missile, a 10-mile missile? ACEVAL was Air Combat Evaluation. What does our airplane need to look like? So AIMVAL, ACEVAL addressed the hardware part of getting better from Southeast Asia. The second thing that came along after Southeast Asia was to improve our training. And it came in a couple different places. If the 4 of us are going to go fly against each other and train, 2 of us are going to get training. The other 2 are training aids. So while that's good flying and whatnot, you're not getting your training that you need, only 2 of us are. So the Air Force said we're going to do dedicated adversary squadrons so that all 4 of us can get good training when we go up to fly. The Air Force did that with F-5s, F-5Es, and the F-5E mimicked a MiG-21 pretty well. Small, maneuverable, hard to see, stuff like that. Flying an F-15 is a big airplane. Flying against a smaller plane was good. The Navy also used F-5s, but they also used A-4s. A-4 is a pretty good MiG-17 simulator. A little bit smaller, not quite so fast, turns really well. That's a MiG-17. Nobody had a MiG-23 simulator. And the MiG-23 came out about the end of Southeast Asia, and the intel communities put that thing out there like that was going to be the airplane that just beat everybody up and just killed us all. It would go faster than anything we had. It would turn better than A4 even. The MiG-23 was built as a scary thing. So we had dedicated adversaries, but we didn't have perfect replication. We didn't have anything for the 23. So some very visionary people said, why not? Let's go get some MiGs and we'll fly them. And to make that happen, of course, required big support at the government. It required some very creative people at the squadron levels and so forth. But they made it happen, and along came this program called Constant Peg. It starts off with MiG-17s, then we got some MiG-21s, then we got some MiG-23s. I came into the program as a trainee. I got to experience training against these airplanes right after I pinned on captain. That was in the late 70s. I got to witness the MiG-17 in flight and the MiG-21, and I will tell you, I'd read the books, I'd talked to people, but reading books and talking to people isn't quite the same thing as the real thing, right? So when I first saw the airplane, we were ingressing like at a red flag exercise. I was at 100 feet in the F-4, 200 feet, something like that. And I saw this MiG-21 go by, and it was like the gee whiz factor. And so the first thing the program really does for people is it kind of gets that gee whiz thing off the table. Wow, I saw the airplane go by. Then a MiG-17 came in and I flew against it, and it was like, holy cow, that was really good stuff. For me, and for our generation of guys that flew fighters, our generation, we were trained. We had the AIMVAL, ACEVAL results, we had the red flag scenarios, we had the dedicated adversaries, we had the MiG program, and along came then Desert Storm, and everybody knows that Desert Storm was very imbalanced in terms of hardware, very imbalanced in terms of training, in our favor. And I guess the moral of that story is, that's why I feel like we were very lucky to have walked behind guys that gave us the motivation to get better from Southeast Asia. So, Constant Peg. I want to talk about Constant Peg. I'll talk a little bit about the 17. I'll talk more about the 21 and 23. Oh, my next bullet, acquisition. We're not going to talk about acquisition. I just can't. To get these airplanes in the middle of the Cold War was not like going down to Walmart and buying something, right? So big government-to-government interfaces, lots of promises made about secrecy and whatnot. Acquisition, parts, all that kind of stuff is just off the table. That part has not been declassified. What has been declassified is we had the airplanes, we flew them in training sorties. When I was there at the end of the program, we had probably in the neighborhood of 12 or 13 MiG-21s and probably 7 or 8 MiG-23s, but we didn't have engines for all of them, so not all of them could fly at the same time. So it was basically, it was a good squadron size. We had 12 Air Force pilots, 3 Navy pilots, and a Marine. Footnote on acquisition. We all know that behind every flying hour, there's at least a maintenance hour, probably more than 1 hour of maintenance. Someone behind their scenes worked on the airplane and made it fly for us. And the same thing in our Air Force life. Man, for every hour I flew in the F-15, I don't know how many maintenance hours were behind that. Really good maintenance people doing really good work. And I want to multiply that times about 100 for our maintenance guys. Because the airplanes that did come to us, we're going to speculate, probably weren't the queen of the fleet of the donating country. If you're going to donate an airplane, are you going to give it the best one? Or the one that's been sitting out in the lake for a while or something like that? So some of the airplanes came with heavy corrosion. Are the engines worn out? Is there a blade missing from the compressor? And here comes this airplane to the maintenance team and said, here, make this thing flyable. No tech data, no engineering drawings, no factory support, no jigs, no tools, all that kind of stuff. If there's a hero in this program, it's the maintenance team that got these airplanes and looked at them and said, well, let's take this wing off this way and see if that works. And let's lay it over here and let's see if we can make this engine work and stuff like that. And the 2.5 years I was there, we flew an 8 turn 8 in the morning, 8 in the afternoon of MiG-21s. And we flew Tuesday, Wednesday, Thursday, Friday. In the 2.5 years I was there, we lost 1 sortie. That's all. So our guys were pretty good. The MiG-23 was not quite so good because it's a much more complicated airplane, didn't have as many of them. And they were in worse shape, I think, than some of the MiGs, the 21s that came to us. More introductory to the airplanes. You know, if you buy a Ford, you kind of have an idea what you're going to get for a car. If you buy a BMW, you're going to get a different kind of a car, right? Because the Germans have a different culture. They make a different type of airplane. And if you multiply that times about 100, you'll have the difference between Western airplanes and Soviet airplanes or East Bloc airplanes, Russian airplanes. And their whole philosophy is different. I can't use the word silo enough times. Maintenance people in Russia don't talk to pilots. Pilots? How many pilots? Ever said, why did they put the switch here? Why did they put that switch there? I did too, until I flew the MiGs. I will never, ever complain about American human engineering again, ever. Well, here's one. F-15, F-16, I'm sure had the same thing, had an inertial navigation system. So you could say, I'll put some latitudes and longitudes in of a point of interest. In Desert Storm, we'd put in Baghdad airports, the Kirkuk airports, and so forth. So if I had to go look at the Tikrit airport, that was my assignment for the day to just sanitize that. I put all those airports in, and I could see that on my radar scope. I need to find airplanes in this area like that. Well, the Russians copied us. They did the same thing with a MiG-29. But they put that control head up by the nose under a maintenance panel. Now, you're not going to fly an airplane and while in flight, reach out and change right, your settings if it's up there under maintenance panel. So they kind of like copied us, but not really. This is an illustration of the difference in cultures and how that difference in cultures creates a difference in airplanes. And when we got in the airplanes to go fly them, it was like, whoa, this is pretty interesting. Let's talk MiG-17 first. That was the first airplane that we had in the program. The guys that flew it referred to it as a little go-kart. You just jump in, turn it on, and go fly. Nothing in it, very simple to go fly. Doesn't go very far, doesn't go very fast. Turns like crazy. No missiles, but it's got 2 great big guns, 2 23 millimeters, and I think there's a 27 millimeter cannon, they call them on there also. So that airplane needs to come into a turning fight to be able to shoot you like that. I'm so fortunate that I could learn this in peacetime because we didn't know that in Southeast Asia. The F-105, fighter bomber, pretty good sized airplane, really fast. 500 knots, 600 knots, doesn't turn that well. But we were all taught, since we fly against similar each other, that if my buddy points at me, I gotta make a brake turn into him. And so F-105s over North Vietnam get bounced by a MiG-17, would do this hard 500 knot 6G turn. The MiG-17 flying at 400 knots and pulling 7Gs would just pull right inside that thing, just like your A4 would, and shoot them down. That never should have lost an F-105 to a MiG-17 if the 105 pilots had had the chance to be trained and to know these things. The F-105 should have just rolled out and gone away. The nose intimidation, reflexively turn and brake turn, They should have said, no, I know better, I'll just turn and run away from this guy, and they would have. My friends who flew this airplane said 350 knots feels pretty good. 400 knots, okay, I can do that. 450, no, I don't like to go 450 because the stick just doesn't work. And they wouldn't even talk about 500 knots. F-105 can go 600, F-4 can go 600, so we should have just walked away from those things. These little guys right here on top of the wing, there's 2 here and a third one, 2 here and a third one. Anybody know what those are? Fences, strakes. The air tends to hit the wing that swept and slide down this way, and this helps keep the air going straight across the wing. The airplane on the right is MiG-21. The MiG-21 can be divided up into old ones and new ones. The late models have the pitot tube on top of the fuselage. The cone here is big on these, and then the spine is big also. There's fuel in that spine. For these things, there's never enough gas. So they put some fuel in these things up here also. The cone here does 2 things. It's got the radar in it. It helps make the air go into the intake properly. If you put your thumb over the end of a garden hose, the water comes out faster. Same thing for air, unless the air is going supersonic. And so anything that's going to be supersonic is going to have inlet geometry design issues to help manage the airflow. See, the cockpit is still kind of on top of the fuselage. You can see pretty well in the 21, except the early model ones were built to go after B-52s. So they'd roll out behind a B-52, 3 or 4 miles behind it, go fast and run up and shoot it with a gun. What's the B-52 going to do for defense? It's got a tail gun to shoot back. And so they put this 3-inch thick bulletproof glass in the cockpit of the early model MiG-21s. You can't see through that at all. If you want to see where you're going, you got to look around that thing in a big way. Particularly as the airplane got older and sat out in the sun and the plexiglass got hurt by the UV rays. That big, big, thick glass to protect the pilot from the B-52's tail gunner. You can't see it real well, but there's a little square right there. Those are suck-in doors. On the ground, sitting still, a jet engine sucks air in. If you're going 500 knots, you don't have suction there anymore. You have compression, air going in like that. What McCoy and Guryakin found out when they built this thing was they didn't make the intake big enough. They needed more air. So you get out your local saw a hole, put a hinge on that thing. It hinges inward. And so on the ground, when your engine is sucking air, push the throttle up, the door opens. Pull it back, it goes shut. Suck-in doors. They're not damped. It's all aluminum. You hear every little creak and whatnot in the airplane, even with the engine on, even while flying it. Doors open, doors close, so you can get ding, 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 ding. And of course, there's one on both sides. They're not coordinated, right? So it's ding, 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 ding. It is funny. But I will tell you that when you're going to go out to fly this airplane for the first time, there's no simulators, there's no 2-seaters, it's just you. And I'd like to tell you that my man card is the biggest one in the room, but it wasn't very big the first day that I went out to go fly this thing for the first time. And Paco Geisler, my instructor, said, you're going to hear a lot of noises, suck-in doors and others. Ignore them, it's okay. And sure enough, there were a lot of noises. I could still hear some of those noises, and I just remembered, Paco, I hope you're right. And he was. Delta wings, big delta wings. Really good turn. This thing would go supersonic, go Mach 2 at altitude. At the lower altitudes, go 500 knots, pull right to 7G limits. And it produces a lot of lift, but it also produces a lot of drag. So that airspeed would just wind right down really quickly. You could go down to like 70, 80, 90 knots and still fly the airplane. Point the nose up 45 degrees, wherever you wanted to do, as long as you did one thing. And that was at 250 knots, I was just slowing down, you push the button to lower these flaps to a maneuvering position. If you got the button down at 250, everything I just said was truth. If you missed the button, everything I just said was a complete and total lie. At 249 knots, 245 knots, the airplane would go out of control very violently. It would just tumble. It would go crazy. Ask me how I know. One time, that's all. That's the only time I did it. After that, I looked down and made sure I had my finger on that button before I pushed it. This is a drag chute. We used it for landing, usually. Our runway is 10,000 feet long. If you managed to get it down on speed in the first 1,000 feet, you didn't really need to use the drag chute. But if you didn't use it and then you went off the end of the runway, it was hard to answer those questions. So everybody used it pretty much all the time. Taxiing the MiG-17 and the MiG-21. How many people fly Cessnas or something that has wheel brakes that turn? That's what these airplanes had. They didn't have nose gear steering. But the Cessnas and the Pipers have hydraulic brakes. So when you push the pedal down, you get brakes now. These have pneumatic brakes. Everybody ever do pneumatic brakes? It's about a 3 to 5 second lag time. You push the pedals to here. Here comes the brakes. And then to let them off, it's about a 2 second lag time to get rid of the brakes. It's a little bit of a challenge. and especially the way it was mechanized. There was a brake handle on the stick that put air to the brakes, and which brakes it went to was a function of where your rudder pedals were. If you had the left rudder pedal in, it went to the left brake, right rudder pedal, right brake, and neutral, it would go to both brakes. And the last thing I'll tell you about the brake system is the air was finite. It didn't replenish. There's a little tank of air just like the one you have in your garage that you aired up, stuck in the airplane, turned it on, and that was your brake pressure. You see where your feet go inside these two tunnels? Inside this tunnel, on the left of this pedestal, is where the gauge is to tell you how much brake pressure you have. It was okay to pre-flight that. You could kind of stand on your head and see that, but in flight, no, you can't. And so you're porting air overboard and your pressure's going down. You really never knew how much you had. The first thing you did was crank the engine and shut it down. And then the next thing you did, we had to taxi out of the chalk successfully, go to the runway successfully, go down and come back, not go off the taxiway, not run out of air pressure. And because you weren't very good at it, you were going back and forth, and so your call sign was zigzag. Zigzag 1 with the towers. Hey, tower, zigzag 1 for taxi. And they'd clear you to do all that stuff. It was a little tricky at first because you think, like everybody else, we've been flying F4s and F-16s and F-15s. You got nose gear steering. You got to think about, I'm not turning the nose wheel, I'm slowing this wheel down. And then to stop the turn, I got to slow this wheel down. And if you do too much of that, now you're stopped and you got to blow the people behind you away with your engine. If you come on the brakes too hard the first time, you'll actually stop the wheel and the nose gear goes 90 and now you're stuck. All you're going to do is spin. You have to get someone to come out and push the nose around to get the wheel to straighten back out. The best thing to do was go about 40 miles an hour or faster, because then you could just use rudders. You don't have to worry about brakes. So high-speed taxi was the approved solution. So that was zigzag 1. The next day would be zigzag 2. Once you pass zigzag 1, zigzag 2 is go out to the runway, put it in burner, and go down the runway to about 140 knots, pull it out of burner. And that gave you a chance to feel the pitch. This is the first time you've ever got to feel the stick to see how sensitive that was and so forth. And then as you got towards the end of the runway, you'd reach up and push the drag chute button to help you stop. The last one I'll talk about on this airplane, when I talk about the designers and maintenance guys don't talk to pilot guys, the fuel gauge. Would we all agree that a fuel gauge is important in an airplane? This didn't really have one. What it has is a dial with numbers on it and a pointer that you can get in the cockpit and you can put it on any number you want to put it on. And then as the engine feeds gas, it's in liters, every 100 liters, it clicks down 1. And that's how you can estimate how much gas you have. So fuel being a maintenance issue and not a pilot concern, the maintenance guys would fuel it. They'd go 2,500 liters, set it to 2,500, and that's the way you'd fly. There was a savior. There's a little red light would come on when you had 500 liters, but we always tried to land with 700 to 800 liters. So 500 liters, I consider that a 5-minute light. So if you have a fuel leak, you don't know it on your fuel gauge, right? Because it's not going to count down. If you take off with external tanks and have to jettison them, you don't know how much fuel is in the tank, so now you don't know how much you have. It was a very simple system, obviously very cheap, but it's got its drawbacks. One day I'm out flying the airplane, and we always want to land like so 700 liters of gas. And I'm out doing a red flag, so I'm about 80 miles east of the field, and there's always that tug of war in your mind. Do I have time for one more turn, one more engagement, or do I need to head back? And of course, usually you make the right decision. One day I didn't make the right decision. I said one more turn, and then I looked down and I went, oh, I'm not going to have very much gas when I land. So I'm heading back to the field, and I'm looking at that thing. It's on 600, and I'm going to land with about 400, and I'm not very happy. And I reached down and I turned it up to 1,500. Now I know it's only got 700 in it, right? But looking at that gauge on 1,500, I was totally relaxed. I went, oh, I can do this. This is not a problem. Now, can anybody explain? I still remember to this day that knowing I was completely wrong, the rational part of my brain knew I was completely wrong. The emotional part of my brain was happy. From then on, I went, I've never touched that fuel gauge again. How it fights, you're good for about one good turn. If I'm attacking another airplane like John in his F-16, he's going to outturn me, and then I'm going to sit here and be stuck at 70 to 90 knots if I got the flap switch down. To get out of that, I'm in a real bind in a MiG-21, because the only way to get out of that is to raise the flaps, dump the nose, and it takes forever to get your speed back up. That delta wing doesn't help that. MiG-23, now we're sitting inside the fuselage. The visibility in this thing is terrible, especially with the canopy down, which is how it flies, certainly. Here's the intakes, look just like the F4. There's a ramp that goes on the inside of that thing, so when it's going to go supersonic, that ramp folds out to control airflow. Swing wing, the lever was all one motion, so you could stop the wing any place you wanted to. There were 3 detents all the way forward. We called alpha position. That was takeoff and landing. You had leading edge flaps and trailing edge flaps, but those only worked in the wing's forward position. If you had the flaps down, you could do anything you want with this lever. The wings weren't going to move. Vice versa. If you had the wings back at all, the flap switch didn't work. Because what you'd do is you'd scrub the trailing edge flap off on the fuselage there. Alpha was straightforward for takeoff and landing. Bravo was, quote, maneuvering mode, unquote. No one that flew the airplane thinks it maneuvered. Okay, it was worth about 1 G for every 100 knots. So if you want to pull 5 Gs, 500 knots. And that's a big, big, big turn. 6 Gs, 600 knots. And then all the way back for speed, and that thing would go fast. Mach 2.3 was its limit, but it wasn't thrust limited. It would go right past 2.3 Mach without even thinking about it. 725 knots was supposedly the airspeed limit. It would go right past 725 and you'd never even know it. There's no buffet, there's no noise. I and many of us exceeded 725 significantly unaware, just because the acceleration was so great. It has leading edge flaps and trailing edge flaps, those for takeoff and landing. It doesn't have ailerons, it has spoilers. The spoilers are interesting. Taking off down the runway, get to about 80 knots, if you're going off to one side or the other, you can put the spoiler up and the drag brings it back to center. So you could use the spoiler for left-right control. The spoilers, as you fold the wings back, decreased in how much spoiler you could get until when you're all the way back, no spoiler. So roll control was only off the horizontal tail differential, which wasn't very much. But if you're doing 700 knots or Mach 2.0, you're not really maneuvering, you're trying to go gently anyway. The late model MiG-21s had this. I tried to use it, I could never do it. This has it also, it's a periscope. Since you can't see behind you by turning, they put a periscope up there to look through that. Really good optics, it's a really good periscope, but it's like a soda straw. It's very awkward, and if you're doing 600 knots, spending 10 seconds looking behind you is probably not the best idea either. In flying fighters, we normally glanced and came back out front, and while you're coming back out front, you process what you saw. You glanced at the fuel gauge, you process what you saw. So you glance behind you and you process what you see. You can't do that. You can't glance in this periscope and do anything. Think of this as an interceptor, not a fighter. At the red flags, what I would call normal speed airplanes, MiG-21s, F-15s, F-4s, fly around 450 knots, 500 knots. And so the ground control intercept is trying to create this to happen. And so we train to see what this looks like on our radar. This guy's a threat, I need to engage him. This guy over here is not a threat, I can let them go. The 23 was to be this guy over here. You'd ask to be 20 miles away and ask to get a vector 10 miles behind, and then burner, sweep the wings back, and you could run them down in a couple of minutes. It was a really good part of this training in red flag was to help the American pilots understand that just because the guy's drifting off the scope, but I don't think he's a factor, he's still a factor. It's a very good piece of the training. Okay, it's not a fighter. Let me try to describe that. The takeoff position, no one ever maneuvered in that. The maneuvering mode was Bravo, 45 degrees back. And one of the first things we do on our first sortie or second sortie where we're trying to learn how to fly the airplane would be a loop. In Bravo, the minimum speed to enter the loop was 550 knots with full afterburner to make it across the top and then come back across the bottom. And that second part is just as important as the first. If you go across the top, you go, made it, and relax. Now you're going to be going so flipping fast down the backside, you have a hard time pulling out from the ground also. In Charlie mode, all the way back, minimum speed was 650 with full afterburner. And minimum, my first one at 650, I didn't get pulled quickly enough, and I found myself up here exceeding the max angle of attack and still hanging on the straps like a space shuttle, and I didn't know what to do. So I exceeded the angle of attack to get the nose down. I had to do that. It's very dangerous to do that. You have to have the yaw ball, you have to have the yaw completely and totally centered because this thing has a very, very small rudder. The rotational axis is not up here, it's way back here. So when you get a little bit of yaw going, like to the left, the wind is also pushing the nose over to enhance that yaw. So anytime you get any kind of angle of attack on the airplane, this loses its effectiveness and you can get yourself in yaw trouble. More than half of our guys departed the airplane in a spin without stalling it. You know, in your Cessnas and so forth, most airplanes, you have to stall it, then yaw it to spin it. Not this thing. This thing would do this at 400 knots. You'd get out of control in the yaw, it would diverge, and then you'd slow down and go into a spin. And a lot of the guys had to use a drag chute to pull out of that thing. What you did have to help was a knuckle wrapper. On the stick would bang your knuckle when you exceeded the allowable angle of attack, and the allowable angle of attack varied depending on where your wings were. They just made me the ops officer. We just had an accident, and so the first thing I did after that ride was I canceled that event in the checkout syllabus. We're never going to do a Charlie loop again. No need to do that. No one's ever going to do this flying the airplane, right? No one's ever going to, when you fold the wings back, you're going to run somewhere. You're not maneuvering. Okay, one more on human engineering, the K-switch. It has a stab-og system that you turn on to help you be stable while you're flying. We call it the K because everything in the cockpit was Cyrillic, right, Russian. It looked like C-A-Y, so we call it the K switch. So when you started, you turned the K on. But most of ours, it was up here, so you could turn it on. One of the first things you did in an emergency was turn it off, so it was handy. One day I went out to go fly the MiG-23, and I jumped in the airplane. I'm to the point where I turned the K on, and I can't find the switch. It's not here, it's not there. I can't call someone and say, oh, where's the K switch on the radio? So I start back here in the cockpit, and I look at every single switch, and there's a lot of them, right? I can't find the darn thing, so I'm going, look at the crew chief. I said, plug in, put your ears on. And I said, hey, I hate to ask you this, but I can't find the K switch. He goes, oh, God, that's this one. He goes, I can't remember where it is either. And so we got another guy to come over, and where it was down this tunnel, up on the left side against the side of the fuselage is where they put the K switch. My first look at the MiGs was in a big tactical scenario. There goes one, there goes one. And the G-whiz factor was satisfied, but I didn't really fly against one to really match my airplane versus that airplane kind of thing. So when the program got mature, first thing we do was we'd do that, 1 versus 1, watch the airplane accelerate, watch it turn, then we could try to fight and stuff like that to give the new person a chance to see the airplane. Called a performance profile. One of the things we'd do is we'd start at 500 knots with the wings in Bravo, 450 probably, put it in burner, put the wings up all the way back, raise the nose 5 degrees, and the airplane would descend at 4,000 feet per minute as the wings swept until you got to about 600 knots. Then it would climb back up and take off. Oh, yeah, the white lines in all of them, the 17s, 21s, 23, this white line right here, when you're in trouble in the airplane out of control, that's where you put the stick. That's what that's there for. And the 21, the time that I never departed the 23. The time I departed, the one time I departed the 21, it was disorienting. I didn't need to have the white line, but yeah, that's where you put the stick. Trim controls. This is the up and down trim. Left and right for the ailerons or the spoilers, and left and right for the rudder are the switches on the front panel there. The fuel gauge we talked about, it's where you know, down here where you don't need to look at it very much. And remember, this is an engine that, the time I oversped it, I was over 800 knots and didn't know it. Paul Stuckey claims to have got to 900. I wouldn't say no. Big engine, huge thrust. And the spec on it is from idle to full afterburner, 1.5 seconds maximum. Most ours all would make it in less than a second. So big engine, big thrust right now. The penalty, the engines are good for about 200 hours. Which is one of the reasons I said earlier we had fewer engines and airframes. That's one of the reasons, because when we wore one out, it took a long time for our guys to fix it. So the way these programs work, there's secret clearances, top secret clearances, and then there's code word clearances. And the code words can be at the secret level or the top secret level, but this was a program that was a code word program. So if these guys were going to come to Nellis for a red flag and take a couple of days off and go fly with us, they would come into our room, our squadron, they'd sign an affidavit, and the affidavit said, I won't talk to anybody about this program. And if I do, it's going to cost me $10,000 and 10 years in jail. I always thought those were imbalanced. But 10 years in jail would get my attention. And then at the end of the week when the training was over, they signed another document that said, I am no longer allowed to talk about the program. Even though I know about it, I can't act like I did know about it. So we were very compartmentalized about that. Oh, I need to talk about 2 more things in this airplane. This is very interesting about this airplane. Most airplanes, fighter airplanes, I call them straight-legged landing gear. You have a wheel and a shock and you land and the shock compresses. There's another one called trailing link. In the trailing link, you have the strut comes down. Now you have a trailing link here, and the wheel is on this thing. So when you land, you have this kind of a thing. It's much more forgiving for hard landings or landing on bombed runways. The Soviet Union wanted to come invade NATO and take over NATO. So they might bomb the Bitburg Air Base and have a crater here and a crater there, or they might have to land their MiGs off field on unimproved terrain. So the wheels on this thing are trailing link. You could land hard and not even come close to stressing the thing. In fact, and this would be a trick you do on new guys, there's a little marker on it. I'm sure you've got the marker on yours also. When this thing flexes up, a little marker shows you how much you flexed up, right? So even if you hit hard, I'm still good. So what did we do on the guy's first ride? We'd go out and bash it all the way up. You'd go,
What'd you do?
The second thing is all of our ground equipment, electrical power, hoses that blow air to start the engines, all that stuff in NATO, totally compatible with the MiG-23. So if they could land on a NATO base, they didn't need to bring their equipment. We would be providing it for them. We flew the airplane stock with the exception of airspeed indicators, altimeters, and radios. Everything else was stock, to include the ejection seat. We were always kind of going, I wonder if this thing's going to work or not, because we didn't know what condition it came in. And so most of us said, well, we're probably not going to want to use that unless we just have to. While I was there, we did have two 21s have an engine flame out. One guy came back and landed, and one guy had to eject. So he used it and it worked. And then right before I went into the 23, we had another guy put one out of control and have to eject in the 23, and it worked. Data points are small, but they're good. We did have a guy elect not to use the ejection seat, and he died in the crash. You know, if you put 10 pilots in a room, how many opinions do you have? 15? 15? The subject of what to do, use the seat or not to use the seat, it was ad nauseum. And the guys that did use the seat, they all had sworn they would never do it. I also need to double down on the first guys to fly the airplanes. I got instructed on how to fly the MiG-21 from a guy that had a lot of time in it. I was fortunate. A couple guys early on got killed in crashes. They didn't have that benefit. So I got to pay homage to the first, you know, all of us Red Eagle guys weren't all the same. Again, all of us that did Desert Storm were so fortunate to have been able to have these training assets.
Thanks to John Mann for sharing his experiences with us in the Constant Peg program. We couldn't cover everything in this episode, so leave your questions and comments below the video, and we'll get to as many of them as we can. And come to the museum and see the MiG-23 and all of our other air and space craft. Now that we've reached the end of the video, if you subscribe, thank you very much. We appreciate that. And if you don't, well, just subscribe already, okay? I gotta get back to work. Catch you later.